Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and we're talking about the ability to get data sets that you can practice your data analysis on. I know that's what I love doing every Friday and Saturday night, just getting data sets from across the web and other resources like that and seeing what I can identify in terms of data analysis. But more seriously,
that's why your schedule's all blocked out on those days. You know?
That's right. That's why. Yeah. That's why I don't host many parties as a result, unless it's a data analysis party, in which case I'm there.
Yeah.
But when people are starting to get into reliability engineering, or they're already in reliability engineering or in a role that's reliability engineering related, and they want to improve or develop their ability to do statistical analysis, one of the issues you find is, okay, well, all right, I've read about this distribution or this method in said textbook, but where are the spreadsheets of numbers that I can interrogate in order to practice my data analysis techniques, which is quite a noble desire for those who want to get better at their craft.
Yeah. And so this question came from Shashir. He was looking for how can I find real life data sets? And it suggested a handful of things. And it was with that notion of practicing. And said that Shashir said that it was working through a couple of textbooks and have small data sets. And some textbooks, like the one by Meeker and Escobar. Let's see, I think I have the title of it here someplace. No, I don't. I think it's Statistical Methods for Reliability. I think that's the name of it. And it's in the second edition, came out last year or 2 years ago. And Bill Meeker has a website that has the data sets for all of the examples that are used in the book. And so there's ways to go through that data set. You get the context, so you can work it, and then you can compare your results to what's in the book. And I think that's a great way to learn it. Yet oftentimes those data sets are sanitized or cleaned up, and they're aiming at a particular technique or process that they're teaching in the book or talking about in the book. In real life, we have all kinds of weird data. We don't know which is useful or not useful, and we need to solve this problem that we're having. Is this new machine better at uptime than the old machine? And we've got 2 years worth of data on the two things on these two separate lines that aren't exactly the same. Go. Or like my boss did one time, he said, we're designing this new product. You need to figure out if it's going to last for 20 years. Go. And I didn't have any data, and so I had to go create data to go do it and then go figure out how to analyze it. The real life problems don't come wrapped pretty with a bow like they do in textbooks.
No. They also, when it comes to data as well, I'm talking to a client right now, and the issue is they're using a well understood device, but in a brand new machine. And the device is intended for, most people would know what it's all about, but it's usually intended for domestic settings or office settings, but this is going to be used as part of a, say, dirty machine in environments which are not as easily controllable and don't have the same level of, humidity and beautiful temperature profiles, et cetera, et cetera, et cetera.
Mm-hmm, mm-hmm.
And it's going to be bumped in different ways. It's going to be used by people who don't own it in different ways. When people don't own the stuff, of course, they are a little less gentle on it. And if it's not their thing, if that thing frustrates them, then that frustrating thing can be subject of fury and punching and things like that. But so it's a very different scenario, and it's not going to be used in a way that is replicatable in terms of the sort of domestic setting for which the thing is supposed to be used. Now, what do you do? How do you then understand the lifetime of that device in a new application. And the
Yep.
reality is, whatever data you might have could be completely useless. Completely useless. You'll have
Uh,
failure modes or mechanisms which drive how long it lasts in its designed environmental setting. And then you'll have other failure modes and mechanisms which will emerge when it's going to be used in this new setting. So the data is useless. What do? You might go and create your data, but then you still need to, even people who say, oh, we'll just test, 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 test. That's cool. But if you don't know how it's going to fail, there's a good chance testing is going to furiously test the wrong thing.
yep.
And so you might want to do a fault tree analysis or a FMEA up front to work out what are the parts that are of that thing that are going to keep you up at night. And they're the parts that you torture to generate data, which you can then analyze.
Yeah.
But
The
yeah,
idea though here is that I mean, the first part is it takes discipline. And I know you got it, Chris. Friday, Saturday nights, very admirable.
Oh, yes, yes, absolutely.
And, you work through sets and you work through stuff. And some of us go to school or take seminars or workshops, and part of the homework or part of the criteria to get through the coursework is to work data sets and you get feedback. And I think that's a way to learn techniques and to hone your skills and do all those things. And yet it's still not quite the same as real data sets. And I think that's why Shashir is asking for it is, should I ask engineering managers for data sets and provide them back my analysis? And I said, I don't think engineering managers or business folks in general, whether in a factory or in a product development team, um, tend to have just random sets of data laying around that they're willing to share
No,
for all kinds of reasons. And their businesses, and somebody might take you on and say, hey, I appreciate your initiative. I'll help you learn, and then, send me your resume. Maybe they're looking for somebody that's really wants to know reliability statistics and is taking the initiative to go do it. That might be, you might find some stat there. And one of the suggestions back was, well, I'm sure there are some data sets out there, and Meeker's set for his recent book is one example of that. And I suspect there are others. And in the literature and papers, there's often data sets available that are not necessarily in the public domain, yet are available to do an analysis. What I think is missing is is learning how to do a regression analysis when you have multiple variables and what fits in the model and what doesn't and so on is all great. Or doing lifetime data analysis on a degradation type product that's you got a bunch of data on. Yeah, you need to work through those. I think that's necessary. Yet I think it misses the big picture. Is you can do I call it a type 3 error. You can work out a perfect solution to the wrong problem.
yeah,
It's the issue is that, yeah, being comfortable with the analysis techniques, whether you're using R or ReliaSoft or some other set of tools, is great. You need some competence in that. Yet be aware of you need to fit the analysis to the problem you're actually trying to solve. It's in context of, is this an important problem to solve? Just because I know how to do it doesn't mean I should, is kind of my point.
right.
And there's business trade-offs, durations, when do you need the answer? How accurate does it need to be? Is this a comparison from the last product to the new product? What are all the context around why you're even looking at this data set?
Right. And it's just where the ponderous professor issue comes into play, where someone might actually be somewhat skilled at a certain data analysis technique. And so every problem then gets solved using that very specific data analysis technique, which is not going to solve too many problems because it's his or her favorite solution as opposed to the right solution. But I think we're sort of what the person who's wrote that comment is pointing out is not so much they might be furiously agreeing with what we're saying, that you don't want to furiously solve the wrong problem, but to be able to develop the skills to be able to solve a lot of problems, you often need to have some numbers to play with in order to get what you need in terms of the skills and experience including what to not look for, or false signals, or false, if,
Well, part of it is you need some feedback. And so it's
right.
working through the textbooks is a great place to work because it's already got a solution worked out there, unless it's in the exercise part and then you have to pay extra for the solution manual or something.
Mhm.
Um,
Which happens.
which happens, but you get an option there. There's a way to get some feedback or can check your answers, kinds of things. Um, the other idea that came up, and I suggested it in the newsletter this week, was how about we gather a handful of data sets and provide some context. What's it about? What's, what kind of, whether it's real or fictional is, but complete enough so that it has some context or business reason for doing the analysis, some question that needs to be answered. And then say, go, all right, do the analysis, leave your results and your methodology and your results in the comments, or send them back to us and we'll post them. And then others are available to, I would encourage others then to check it out and what
Mm-hmm.
makes sense, what doesn't make sense, give some feedback. And I know that we've got in the community, we've got skilled statisticians and reliability professionals of all kinds and all kinds of skill levels. So I think providing feedback to each other would be very much like an engineering manager saying, well, what is this analysis? And you explain it and they say, well, what about this? Or what about that? Or how does that work here? Those kinds of questions could be real,
Mm-hmm.
or real-ish, I should say. That, yeah, I don't think it would be terribly difficult to come up with 10 or 12 sets of data and the associated descriptions of them and say, all right, go do your
Yeah, the
analysis, see what you get.
other problem is a lot of real world data sets are either one, not useful, or two, require an incredible amount of interrogation to uncover useful stuff. I remember one scenario was where one of my clients was trying to work out what was happening with a component on its device, mechanical component, which was being used in a brand new application. It's a different scenario to the one I was talking about previously. And they were trying to look to see if it was, poor quality manufacturing. And one telltale sign for that is being able to identify any infant mortality or wearing or anything like that. It doesn't guarantee that that's an issue, but if you see an absence of it, then it usually means that, hey, you need to look somewhere else.
Yep.
And so the data they had was incredibly challenging to interrogate because they had times to failure in terms of calendar times. And so you had to first estimate the distance as opposed to calendar time usage based on other things. And then once you do that, then you're supposed to, there's lots of sensor data. So some things were still being used, some were not, some incredible amount of sensor data, not just all, some was interval, some was right censored. And so as soon as you start doing any sort of, you cannot use off-the-shelf software for that because off-the-shelf software struggles big time. You really need to use the sort of gold standard MCMC approach for that with some ideas about how to essentially fit in the right model for it to look for the stuff. And so I was able to essentially found that there was absolutely no suggestion, no evidence of infant mortality or wearing, which meant that quite simply the component they were using was not robust enough for their application. So it wasn't quality control. It was either one, that every single thing that they were getting was identically weak, which usually means, or their specifications were wrong. Usually it's the latter. Usually the specifications are wrong, which means everything becomes identically weak as a result.
Yeah, it just
Appears
gets
to be identically weak.
overstressed right out this gate, and then
Right.
it's gone. Yeah, I was talking to a client about that just just recently, and they're desperately trying to prove it's the manufacturer's fault.
Yes, that's that happens a lot, doesn't it? But
Yeah,
but by no means would that data set be any useful for anyone who's just trying to dip their toe in the water, so to speak.
well, that might be a challenge. Is it wouldn't be hard. I think I've got original data set someplace that the bulk of the time spent with the data was trying to figure out how to get it into any analysis package. It was,
Right.
there's a bunch of text interspersed with it. There was asterisks on some of them. There is special characters. There was a great big gap in the data for 6 months. I'm like, well, what? I know you ship thousands of units over this time. Do you have nothing on those? No, they went, to somewhere else. We don't know where they are, if they work or not. Uh, it's like just dealing. A big part of dealing with data sets is, the regression analysis in and of itself is worth studying and understanding. Yet almost nobody gives you a data set that's nice and clean and has all the figures in a nice orderly fashion in a table. It
Mm-hmm.
comes in a database query that is a nightmare. I know where to get a data set like that just for practicing data cleanup is from NOAA for the weather data. If you want to understand what's the range of temperatures you expect for say Bakersfield, California, it's seasonal, it day and night temperature variations, all the other stuff. Yet the data sets from those stations is messy in
Yeah.
about a dozen different ways. And what's a technique to clean that up? And how do you go about doing that? And maybe provide that raw data and then say, here, give us a distribution plot of this. What's the 10th percentile, high temperature, low temperature, median temperature, stuff like that? What's the seasonality of it? What's the time series of it? Not necessarily reliability data analysis, but the goal would be just, well, how do you clean it up? And if you ignore it, or delete lines and do all that other stuff, you will get a different answer depending on how you approach the messiness of the data set. Oh, I'm getting ideas left and right here. I should assign action items. You up for next Saturday, Chris, creating a new data set or two?
Well, the other thing I can do is just generate random data through MATLAB, which might have 5% experience infant mortality, and the rest do this and the rest do that. So I suppose, but if I was to do that, which would be relatively straightforward, I'd really want to know what our listener or question asker is trying to work on in terms of generating their skills.
Well, you can go get a PhD just in regression analysis and spend tons and tons of time in textbooks and classes. Because, just from the reliability data analysis, there's the very simple, I've got a set of time to failure and a perfect test that ran them all to failure. And what's the regression? What distribution fits that? And what did we learn of our time to failure pattern? Well, then there's censoring data, and then there's left, right, and intervals, and how do you deal with it? And then there's degradation data, and it's a different approach. And then you're running a test at 3 different stress levels. It's not field data. It's not a single stress, or you got multiple stresses, and on and so we can create scenarios and data sets for all kinds of different analysis. And I agree with you. So what if it's categorical? How do you deal with that? So we could create, and I think taking inspiration from Meeker's work and from Wayne Nelson's work and others that have published stuff, we could find all kinds of cool examples for doing stuff. But I like the idea where it's, there's a set of data that's, it's got a reasonable slope on a beta curve, for example. It's failing at a relative rate. And all of a sudden there's a spike. It just shoots straight up. I call it a hockey stick approach, where this new failure mechanism rears its head. How do you deal with that? Those kinds of things. I think there's some ways to go about doing this. And if nothing else, is just to have a pointer saying, well, here are reasonable data sets available, plus their tech-related textbooks. So somebody that really wanted to dive into this stuff really could. But real life is, I think what's missing in the textbooks is the real life part, is the messiness of it.
Right. And
the fog of data. That's what we call it, the fog of data.
Well, there's also experience too, because, if you think about a Weibull plot, for example, when I generate 30 Weibull random variables which should go on a Weibull plot.
Mhm.
Sorry, which when plotted in a Weibull plot are nominally supposed to approximate a straight line. Well, of course, with 30 data points, those data points aren't plotted in a straight line. They're going up and down because of the noise associated with the random process that is failure slash generating those random variables through Excel or MATLAB.
Mhm.
And so the inexperienced data analyst will see, oh my goodness, there's 3 or 4 lots separate mini failure mechanisms there, but it's experience which tells you, no, that's actually what it looks like.
Oh yeah, definitely. It's so varying the amount of variability in the data set would be just another scenario of here's a data set that's pretty clean. Here's, and it fits a Weibull very nicely. It's almost too perfect
Right.
versus one where you crank up the variability a bit and then you're like, well, this is also a Weibull curve, but it's messier and the uncertainty about how many are actually going to fail at 10 years that's harder to tell.
Right.
Um, the there's the variability of the variability in the data set. There's measurement error in a data set, which may or may not be linear or great and useful. Uh, there's also the failure mechanisms change over the lifespan of a product in its field, early life and wear out and so on, or just different failure mechanisms. I think we could easily create a dozen or a dozen data sets that would explore all kinds of weird stuff and try to get at that idea of here's how to build experience to understand what you're looking at in the analysis, the clues that come out when you go through the steps to create a regression.
Absolutely. Yeah. I mean, yeah, a few things are springing to mind. I mean, we should have some structure. We just want to throw some data points. Here's a spreadsheet of numbers. Go. It
Oh no,
needs a
no,
little
it would
bit,
have to
little bit
be
of
a
context.
context of this
Yeah.
is why we need this and here's the situation.
Mm-hmm.
Um, Yet in what I find in real life, it's rarely clear.
Right.
There's an engineering part to the problem, not just a statistical part.
Yeah, but you got to know what you're looking for. I mean,
Yeah.
as I preach to my students is before I do any data analysis, I get a spreadsheet of numbers. I say to myself, well, I'll look at what are we modeling? What are you expecting to see?
Yeah. What do you expect
And
and what are you trying to determine? What's the
right
question you're facing?
now, if I look at it and I speak to people and say, well, we're experiencing early phase this and this, that, and the other, and say, okay, yeah, it's tending to happen this way, or it's after 3 years this happens, or what have you. Very anecdotal.
Mm-hmm.
If you go, okay, so that's evidence, that's data. It's people might not think that something besides a number is data. It absolutely is data.
Yeah.
Um, but then if I did data analysis and lo and behold, it shows that there is infant mortality for the first 3 months, or lo and behold, it shows there's this sharp uptick in hazard rate after 3 years, that's way more powerful. Way more powerful. Or even if I just look at the situation myself or the device I'm modeling, I go, okay, I know this thing. I know this sort of technology. I know hydraulic this. I know chain connectors this. I know ball bearings that. I would expect to see this key signature in my data analysis results. And if I
Mm-hmm.
see it, it's more than anything else validation beyond all the other validation steps you go through, but it's validation that you're on the right track.
Yep.
But if you see something completely haywire or a time to failure model, which is not a reliability model, then you go, okay, someone stuffed something up. What is it?
Yeah.
Often it's me, but
Yeah. No, I've done plenty of false starts and analysis, yet it's I always double check. I always look at it and go, is this, get other people look at it and here's the story it seems to be telling me. Does that make any sense? And they just laugh and laugh. And you have to be skeptical. If I dump data into a Weibull plot and just go, here's the answer, here you go, and it's predicting a negative lifetime of 6 months for all of the units you make, well, that's kind of not believable. They at least start at zero. Um, but Yeah, I've done some analysis. And this goes way back. When I was in college, I screwed up a really easy problem in physics by getting the sign wrong. And so I ended up with negative mass as a result and underlined it even and said, here's my answer. And I didn't step back to go, well, that would either be an amazing breakthrough and I'd be a Nobel laureate, or I made a calculation error and to get the sign right.
Yeah, it's happens to the best of us.
Well, thank you for that compliment there. Well, anyway, I think it was so. Hopefully, Shashir, and I responded to the message and said, "Here's some idea, some suggestions and some of the barriers of going straight to engineering managers and asking for data sets. You can try. You might find a nice mentor that, or a really suitable person that will help you, learn statistics and understand what you're going after, and that might be a win-win for both parties. I don't think it's impossible. I think there's a lot of barriers there. Yet I think it sparked this idea that, well, why don't we either list what's available and or make some and see what happens? So if you're listening to this and you're going, oh, that would be cool. I'd love to get some of that to expand what I know, and try my chops on, say, degradation data, because I've never used that before, yet I can see where it might be useful. And let me practice and we have something to try it on. The other part I'm interested in is that if we set a data set up and it should be a Weibull plot or whatever it is, well, if you're using XYZ package or approach, or you do it manually or you do it with AI, what kind of answers do you get? How variable is it depending on what approach we use, what software we use? That might be interesting in and of itself. Anyway, you know how these things work with me. I get lots and lots of ideas, and then I'll have to see if we can figure out how to actually make it happen. So if you're interested or would like to help contribute to this idea, let us know. Head over to ascendoreliability.com/go/SOR. Lots of ways to get in touch with us. Chris and I and the other hosts are available through LinkedIn and our About pages. And this question came through directly as email. The previous episode we did was a comment on an article. We've had comments on podcasts that we've used for shows. A good number come through LinkedIn, comments directly to us through LinkedIn. So lots of options for you. And we look forward to hearing from you. And sharpen your pencils or keyboards or whatever it was we do these days, because we may have some sample problems coming your way that are not true false.
Absolutely.
All right. I think that's a wrap. Chris, what do you think?
I think the data suggests it is.
All right, there you go. Good talking to you, Chris. Talk to you soon.
Thanks, Fred. Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.